In this discussion video, we are going to do a practice factoring question. So I want to begin by reviewing some of the factoring formulas we had: difference of squares, difference of cubes, and sum of cubes. So I want to first give you 1 minute to fill out these formulas and see if you can remember what they are. 4, 3, 2, 1, pause it and try that for a minute. Alrighty, so hopefully you did that. Hopefully you paused it for a minute to try to fill out those formulas. Difference of squares is x minus y times x plus y. Difference of cubes is x minus y times x squared plus xy plus y squared. And remember the trick to get sum of cubes quickly from difference of cubes. What you can do is you can replace y with negative y. If you did that, this would become x plus y. That sign would change. And then you'd get x squared minus xy. And then you'd get plus negative y squared would still be positive, because when you square that negative, it becomes positive. So plus y squared. Alrighty, so we have these three key factoring formulas. And now let's try a practice problem. So this is from worksheet number 1, question 4c. Let's factor 27p cubed minus 3p plus 8q cubed minus 2q. So I first want to give you 1 minute just to get started thinking about, what's the key idea? How do I begin? So it won't be enough time to finish the question, but just think about key idea. 4, 3, 2, 1, pause it and think about that key idea. Alrighty, let's talk about it together now. So the key idea is that there's 4 terms here, exactly 4 terms. And when there are 4 or more terms, one strategy that often helps is to try factoring by grouping. So now that we have that in mind, I'm going to ask you to pause it one more time, this time for 3 minutes, to see if you can take it from here. 4, 3, 2, 1, pause it for 3 minutes and see if you can finish it from here. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. I'm going to do this in 2 ways to show you, remind you what it looks like when we pick a grouping that doesn't work and what happens when we find a grouping that does work. So in my first attempt, let me rewrite this: 27p cubed minus 3p plus 8q cubed minus 2q. Let me also write it one more time here. P cubed minus 3p plus 8q cubed minus 2q. In my first grouping, I'm going to try to group the first 2 terms together and the last 2 together. In the first 2, I can factor out 3p. And I'll be left with 9p squared minus 1. From the second group, I can factor out 2q. So maybe I'll factor out plus 2q. And I'll be left with 4q squared minus 1. So now, if I look at this first group and that second group, there are no common factors. No common factors, which means that this is an incorrect grouping. So I'll put a sad face. This grouping, unfortunately, did not work. All right, so now let's try to attempt this differently. Let's think about a different grouping. So one thing I notice is 27p cubed and 8q cubed are both perfect cubes. So maybe let's group them together and group the other 2 terms together. So if I do put 27p cubed and 8q cubed together, I notice that both of them are perfect cubes, and I'm adding 2 perfect cubes. 27p to the third is, in parentheses, 3p being cubed. 8q to the third is 2q in parentheses being cubed. So I'm going to have a sum of cubes, so that's good. And then from the other remaining terms, I could factor out a negative 1, or just a negative. So negative, and I'll be left with 3p plus 2q. And if I use sum of cubes now, On these first two terms, I'll get 3p plus 2q times the first thing squared minus the first thing times the second thing plus the second thing squared, 2q squared. Alrighty, and then I have that minus 3p plus 2q. And now notice that the groups have 3p plus 2q in common. So I'm going to be able to factor that out, 3p plus 2q. When I do factor it out, from the first group, what's left over is the three terms in the parentheses of 9p squared minus 6pq plus 4q squared. And then from the second group, I technically have this 1 in front of the parentheses, so I'll be left with minus 1. And that is my factorization right there.